solving equations using logarithms. So in an earlier lesson, we talked about how to solve stuff like 2x equals 8, where the key was you try to get these to be the same base. And like in this case, it's like, oh yeah, 8 is 2 cubed. It's 2 to the x. And once they're the same base, you just solve the exponents, so x equals 3. But what happens when this is not possible? When this 8 is something like a 30, like 2x equals 30 right here, right? There's no way you can rewrite 30 to be 2. So in that case, what we do is we take the log of both sides, or the natural log. So in this case, bases can't match. You want to take the log of both sides, or natural log of both sides. I say natural log because they're both logs, but natural log is 2 letters instead of 3, so it's a little similar. So let's rewrite this and show you how to do it. So let's say we have that. Like I can't rewrite 30 to make it a power of 2. It's not possible. Remember, my powers of 2 are 2, 4, 8, 16, 32. 30 doesn't fall in that. So what you do is you take the natural log or log of both sides, like that. So it's like natural log of this, natural log of that. What does that let you do? Well, this is a power. And remember, one of our rules is if you have a log to a power, you can write that to the front. So x equals natural log of 2 equals natural log of 30. Like that. Then we just divide both sides by natural log of 2. And we get x equals natural log of 30 over natural log of 2. Now keep in mind a couple things. This is not natural log of 15. This is natural log of 30, which is some number divided by natural log of 2. You can't just like cancel these out. This is your answer, or you put in your calculator to get a decimal. But either way, it's fine. Let's look at part B, right? So we want to use our calculator to figure out what that is. So all I'm going to do here is go natural log of 30, close the parentheses, divided by natural log of 2. And we get 4.906. Remember, this should be decimal, because 2 to there's no power of 2 that gets you 30. It's in decimal. And actually, you could check your work. 2 to this answer here should be about 30. Remember, that's real rounded. That's why it's really close, because they rounded off right there. By the way, remember I said you can't reduce this to natural log of 15? Let's see if we try natural log of 15. What does that give us? 2.79. That's not the right answer, right? So don't reduce. Keep it like this. Okay, next one. This is a harder one, but the same concept. So I cannot rewrite 5 to match 2. So what we're going to do here is take the natural log of both sides. So I get natural log of 2x plus 4 equals natural log of 5, 2 minus x. Now in this case, I can move these powers to the front. You gotta be very careful here to put parentheses. Right, a lot of people forget to put parentheses and they just look at this as x plus 4 natural log of 2 and 2 minus x natural log of 5. It's not like that. It's these two are together, not these two guys. Same thing here. These two are together, not this guy. So after you have that, we want to distribute. We're distributing here and not just solving it because you have an x on both sides. So you gotta distribute so you can get them on the same side. So I get x natural log of 2 plus 4 natural log of 2 equals 2 natural log of 5 minus x times natural log of 5. Right, so took natural log of both sides, move this to the front, distributed this to both of them, I get this. Now what happens here, we have an x on both sides. So we want to put all the x's on one side and all the numbers on the other side. So I'm going to move this x over here, and I'm going to move this number over there. So I'm going to go plus x natural log of 5, and then minus 4 natural log of 2. So I'm going to get this. X natural log of 5 plus x natural log of 2 equals 2 natural log of 5 minus 4 natural log of 2. And since you have you have 2x's on this side, you could factor it out. Natural log of 5 plus natural log of 2 equals. Now it's your choice here. You could leave it like this, or you could try to simplify it, like move the 2 to the front, move the 4 to the front, and simplify it that way. Either way is okay. Let me just leave it like this at first, and then we'll simplify it later. Okay, let's see how times this part, right? This is an ugly one. It's ugly when there's an x on both sides. So we had to do all this. So we took the natural log of both sides, we move this to the front, we simplified, we put all the x's on one side, and then we factor out an x. So what do we do next? Well, I have an x by myself. Just divide by this guy. And there you go. X equals this mess. Now we could make it a little nicer, especially down here. Natural log of 5 plus natural log of 2. The multiplication, addition means multiplication. So this is actually natural log of 10 on the bottom. You can make the top a little nicer if you wanted to, right? That would have been natural log of 25 minus natural log of 2 to the 4th is 16. So natural log of 25 over 16. That's what x equals. But either way, it's ugly. So it's either this ugly or it's this ugly. It's your choice of ugly. Next one. Now we're going to do it with ease. So how do we solve ease? It's actually a little nicer. We're going to take the natural log of both sides, right? If you want to cancel out the e, you got to take the natural log of both sides. Because then we get, I'm going to rewrite it first. We get natural log of e, which cancels each other out. You just get the x moves to the front. So x, well, technically what happens here, you move the x to the front, and then it's x natural log of e. Natural log of e is 1, so it's just x equals natural log of 30. So like that. Now on this one, you can't take the natural log of both sides because the 3 is in the way. Nothing would cancel out because the 3 is there. So divide by 3 first. Get the 3 out of the way. So I get e to the x over 2 equals 7. Then we take the natural log of both sides. Because now I can cancel out the e. Again, what happens here is that x plus x over 2 moves to the front. And then the natural log e cancel out. So I get this. We times it by 2. Now if you notice, I put the parentheses there on purpose. This is not natural log of 14. The 2's, it doesn't work that way, right? This is a number, and then you times it by 2. So what this actually is 2 natural log of 7. Or if you want, natural log of 7 squared, right? You move the 2 to the front, and you get 2 to the power, and you get 7 squared, or 49. So either way. But it's not natural log of 14. So that's how you solve when you can't get the base to be the same. You take the natural log of both sides and then work your way from there. When it's an e, it's nice because those cancel out. Find the exact points of intersection of this and this. Check your solution using technology. So normally we do y1, y2 and graph and see where they cross. But it does say check your solution using technology. So we're not going to use, they want us to not use technology at first. So we're going to solve it the old-fashioned way, right? We want these to intersect, we want these to equal each other. We get e to the x minus 3 equals 1 minus 3 to e to the negative x. Now, right, e to the negative x is what makes it look funky, like what's going on here. And I think we have to use a trick. So what we're going to do is let's move everything over to 0. Let's set equal to 0. So we're subtract 1, and we're going to add 3e to the negative x. So it's going to be e to the x plus 3e to the negative x minus 4 equals 0. Now, how to get rid of e to the negative x? Also known as 1 over e to the x. Probably a little nicer if I write it that way. What we're going to do is we're going to multiply everything by e to the x. So we get rid of that fraction. We can do that because it's not going to equal 0. E to the x never equals 0. So we're just multiply everything by e to the x to get rid of this denominator. So we're going to multiply it out. And we get e to the x times e to the x, which we all know is e to the x squared. Over here, these cancel out, and you just get 3. Over here, I get negative 4 e to the x. And e times 0 is 0. Now I could rewrite this middle part to be like this. Hey, and I could factor this, right? Pretend this is a w. This fact, that's a 3. This factors perfectly, right? As long as you just ignore that, pretend it's a w for now, right? This factors perfectly. Two things that multiply, you get 3, but I take a negative 4 is w minus 3, w minus 1. So you split it, you get w equals 3, and w equals 1. Remember, that wasn't our question. W is e to the x. So rewrite it. E to the x equals 3, and e to the x equals 1. Like that. And then how do you solve this? Take the natural log of both sides. x equals natural log of 3, and x equals natural log of 1. By the way, natural log of 1, 0. So we get natural log of 3 and 0. That's how you solve it by hand. Now it's a little messy, especially right here, right? When you have anytime you have something on the bottom, you probably want to get rid of it. So you just multiply everything by that denominator to get rid of it. In this case, it made it something nice and factorable. And I guess we're going to do the same thing with this one. And then we just did it. Let's more practice. So it's going to be the exact same idea. Let's move, this is negative x. Let's move everything over there. So plus 3, plus 3. I'm going to get, I should actually move it, let's move it the opposite way. Sorry about that. This is going to be my x squared. I don't like that to be negative. So we're going to add the x to both sides and subtract 3 from both sides. So we're going to get this. Let's rewrite this so it's a little easier to see. Right, so we wrote this as ex on the bottom. Move this over, move that over. So we get this. Just like before, we don't want that thing in the denominator, so let's multiply everything by e to the x. This just gets me 0. Over here, distribute. This one and that one cancel out, you just get 5 minus 6 e to the x plus ex times ex is e to the x squared. Now I'm going to rewrite it up here so that it's a little more normal. So we get e to the x squared minus 6e to the x plus 5. Now again, it's like last time, if I pretend that's a w, it's actually a lot easier to factor. W squared minus 6w plus 5. Well, that factors two things multiplied to get 5, add to get 6. W minus 1 and w minus 5. Split it, w equals 1 and w equals 5. But again, that wasn't what w was. W is e to the x, so rewrite it. E to the x equals 1 and e to the x equals 5. And then we just have to solve that. Take the natural log of both sides. So I get x equals natural log of 1 and x equals natural log of 5. Natural log of 1 equals 0. So there's our answer. 0 and natural log of 5. So again, we did that twice, but that's how you solve it when you have two things intersecting, right? In this case, e to the negative x moves to the bottom. And anytime you have something on the bottom, you probably want to get rid of it, so multiply both sides by e to the x, and then you get something in the quadratic form. If it's in quadratic form, make it a little easier on yourself. Make the middle term w, and see if it factors. Okay, last one. A farmer monitoring an insect plague finds that the area is affected by insects is given by this formula here. AN equals 1,000 times 2 to the 0.7 n hectares, where n is the number of weeks after initial observation. Use technology to help sketch a graph of AN, hence estimate the time taken for affected area to reach 5,000 hectares. So it wants to use our calculator to solve it first. Okay, so remember how to do this? All we're going to do is go to y, we're going to graph it, and we're going to set 1,000 times 2 to the power of 0.7. Now we don't have an n, we're just going to use x. So we're going to graph like that. Now, they want to use to estimate the time taken for the area effect to reach 5,000. So I'll make y2 be my 5,000. Now remember, when you graph, you're not going to see, especially on this normal graph, you're not going to see anything. You got to fix the window. So let's go to my window. Now remember the way we want to do it. If you want to see anything, you got to go to at least, we want to be across 5,000 or y, right? As high as 5,000, some are y. About 5,000, but I want to make it a little higher because I always like to give myself a little buffer. So let's make it 6,000. Now my x, 10 might be okay, but my feelings they're not going to cross for a while, so I'm going to put this like at 100 or something. See if they could cross at 100. Then we hit graph, and 100 was way too much because they crashed very shortly. So let me go back to my window. Let's maybe go negative 1010. See how that works. That was 110, wasn't it? Yeah, I noticed. Come on. 1010 is what I want here. Put clear, just make sure. So that's better. And there's 5,000. So I'm going to cross somewhere right there. So let's figure out where they cross. Second calculator intersect. And whenever you press up or down, it switches between the two graphs. And you just want to get closer to the graph. First curve you put yeah, then it jumps to the second curve. You got yes, that's my second curve. Then it says guess. You put yes, guess, please. And I got my answer of 3.317. So it's take about 3 years. always like to show a picture of what we're graphing, so you have some idea of what it looks like. And then I get n equals 3.1704. IB is usually 3 sig figs, which would be 3.32. In the second part of this, we want you to check your answer using logarithms. So let's solve it by hand, essentially. So, well, for the most part. To use the calculator a little bit. So, right, we want to set 5,000 equal to 1,000 times 2.7n. So we want to do this by hand. So the first thing I do is we want to get rid of this 1,000. I want to get only the power here. So we're going to divide both sides by 1,000. That gives us 5 equals 2 to the 0.7n. Now what happens here, you generally want to get the bases to match. Not going to be possible right now. So what we do is we take the natural log of both sides. What that lets you do is lets you bring this to the front. So I'm running out of space here. Let me erase this because I don't need that anymore. You can always rewind if you need it. And I get natural log of 5 equals, remember, remove the whole reason we're doing natural log is to move this to the front. 0.7n natural log of 2. Right, so the whole point here is we're trying to solve for n, so we're going to divide by natural log of 2. These cancel out. Now we're going to use the calculator anyway, so let's bring our calculator back out. Let's divide this before I divide by 0.7. So let's go back to the home base. Natural log of 5, don't forget to close the parenthesis. Divide by natural log of 2. And I get 2.32. So 2.32 equals 0.7n. Then it's divided by 0.7. We get n equals, well, approximately, we're going to round this. Divide that by 0.7. And we get 3.317, right? 3.12. So we get the same thing either way. So that's how we solve it by hand, essentially. You have to calculate a little bit to do the multiplication, but how to solve it algebraically compared to how to solve it with the calculator. So there we go, and that's the lesson.